Hi, in this video we're going to be doing a few problems on molar solubility and Ksp. So the first question asks, which of the following is more soluble in water? So which is the more soluble? It's going to be BaOH2. Why? Because the Ksp is higher. Higher the Ksp equals the more soluble it is. Next, the solubility constant Ksp for nickel 2 carbonate is this. So let's write the balanced chemical equation for the dissolving process. The process would be nickel, NiCO3, forming dissociate into Ni2 plus CO3 2 minus. The equilibrium expression is going to be Ksp is equal to Ni2 plus times CO3 2 minus, which is equal to our Ksp, which is 1.3 times 10 to the negative 7th power. Find the maximum molar concentration for all ions in the solution with the molar solubility of the solution. So let's see, Ni and Ni2 plus and CO3 2 minus. Alright, let's create a right chart. Initially, they both have 0, and it's plus S, and it's S and S. So 1.3 times 10 to the negative 7th power. We're looking for the molar concentration. It's going to be S squared. And now what is S equal to? S is going to be equal to square root of 1.3 e to the negative 7th power, which is going to be 3.6061 times 10 to the negative 4th power. And this is going to be equal to the molar concentration of Ni2 plus and CO3 2 minus, since both of them are equal to each other and both of them are just simple S. Next, the solubility constant for Ksp for calcium hydroxide is this. So write the balanced chemical equation. Alright, so we're calcium hydroxide, CaOH, Ca is 2 plus, so CaOH2. And this will form Ca2 plus 2OH minus. Write the equilibrium expression. Ksp is equal to Ca2 plus times OH minus squared, because we have 2 moles. Now find the molar concentration for all the ions. Alright, so Ksp, let's set this equal to 6.5 times 10 to the negative 6th power. So the next step we're going to do, let's see, so this is going to be 1S, and this is going to be 2S. Alright, so 6.5 times 10 to the negative 6th power is equal to S times 2S squared, which is equal to 4S cubed. So we divide 6.5 e to the negative 6th power by 4 and take the cube root of that, which will be S is equal to 0.012117, 118, and this is going to be equal to the concentration of Ca2 plus, and when you multiply this number by 2, which is 0.0235, which is the concentration for OH minus, because there's 2 of those. Alright, so to find the maximum mass for calcium hydroxide, we're going to be using our S. Our S is 0.0118. So 0.0118 for moles per liter times 1 mole on the bottom. Let's see, calcium hydroxide. Calcium Ca is 40.08 plus hydroxide 16 plus 1.01 times 2, 74.1. So now that is grams. And then we're also looking in 100 milliliters. So on top, we're going to write 1 liter. Down there, we're going to write 1,000 milliliters. And then we're going to times this by 100 milliliters. So this will get us a final answer of, let's see, 0.0118 times 74.1 times 1 times 100 divided by 1,000. This will give us 0.0874. And it's going to be molar. This is going to be the mass, grams per 100 milliliters. Over here, moles and moles cancel, liters and liters cancel, and milliliters on the milliliters and grams remain in the end. So this is how we got an answer of 0.0874. Now, last question. It says a 250 milliliter saturated solution of silver chloride is prepared at 25 degrees. The molar solubility constant Ksp for silver chloride is 1.8 times 10 to the negative 10th. So what is silver chloride? Silver chloride is AgCl. Those are form Ag plus Cl minus. Equilibrium expression is Ksp is equal to the concentration of Ag plus times the concentration of Cl minus, which is equal to 1.8 times 10 to the negative 10th power. Find the molar concentration for all the ions. So it would be S squared. 1.8 times 10 to the negative 10 is equal to S times S. And the S will be, let's see, square root of 1.8 e to the negative 10th, which will be 1.34 times 10 to the negative 5th power. And this is going to be equal to the concentration of Ag plus, which will be equal to the concentration of Cl minus because they're the same. So these are the molar solubility for both of these. And then finally, what are the molar concentrations for all the ions in 50 milliliter saturated solution of silver chloride? Alright, so concentration of concentration of Ag plus, once again, is going to equal to the concentration of Cl minus because they're the same moles. And this is, in 500 milliliters, it is still going to be 1.34 times 10 to the negative 5th. The molar concentration is going to be the same regardless of the volume, as long as you're in a saturated solution. So that is something that you need to know. If it's a saturated solution, the molar concentration is going to be the same regardless of the volume of the water. So that's it for this video on Ksp and molar concentrations. Thanks for watching.